Okay, so as the title suggests, we're going to talk about the fuel economy, which is, I don't know, I think at your age, you're not really all too familiar with what that is. I think you have an idea, right? But I want to make sure that you understand what fuel economy is because you got to be a smart buyer, right? So this is the formula. Fuel economy is liters divided by kilometers times 100. If you have a highlighter, right? Oh, Daniel, could you turn off the front? Thank you. Appreciate that. It's always expressed as liter per 100 kilometers. Sometimes the fuel economy is also known as the fuel consumption. So don't let that, it's like finance charges the same thing as total interest, right? Finance charge is TI, okay? So keep that in mind. Fuel economy of a vehicle, here it is. This is a definition. Liters required to travel 100 kilometers. That's basically what the fuel economy is when you calculate it. It's how many liters you need to travel 100 kilometers. That's like a standard way of when you go to a store, when you go to the deli, superstore, or Save on Foods, whatever, if you go to the deli, the prices are per 100 grams or per kilogram, right? And so fuel economy is just per 100 kilometers. This is important. A high fuel economy, it means a higher cost of driving. A smaller fuel economy, right, it's a lower cost of driving. Like, so you want a smaller fuel economy. The lower that number, the better you're off, okay? The better off you are. So if we just go back up here for 1 second, this is what I'm sure that if, remember the times you used to go to the mall, right? Before COVID, more than now, right? But you remember the cars that they had displayed there sometimes that you could win? They would have a sticker like this on the window. Like it's a lot bigger than it's on here. But this is kind of like a standard, like the government of Canada has developed this template, so all car manufacturers have to have this somewhere when they sell it. And it's hard to see, but forget about this. This is the American side here. Forget about that for now. But this is telling you that this particular car uses 9 liters per 100 kilometers, right? And it's hard to see, but if you zoom in, there are 2 different numbers. 10.7, do you see that? 10.7, what does it say next to it? City, right? And 7.5, highway. So what are you talking about? There's 2 different fuel economies, and then there's a big 9. So the 9 is the average, and this is what a car consumes if you travel highway versus city. Now, why do you use more when you drive city compared to highway? I don't think students always understand that, but why do you use more fuel when you're driving in the city versus driving in the highway? Joey? Sorry? Yes, so Joey said having to stop. So in the city, you have to stop a lot, right? Yes, and on the highway, you're just coasting, right? You have cruise control, right? Like you're just going 100 the whole time, hopefully. 100, guys, don't speak. But the car, even a plane, you know, planes, they use most of their fuel during takeoff, right? When they have to, like, from a stop, get that speed to get up, and then they coast. When they're coasting, then it's a lot less, right? So a car is the same thing. Every time you have to start it and go from a stop to 50 or 60, you're going to use a lot more fuel than just keeping it at 100 or whatever. Like the RPMs on your engine, right? When you accelerate, it goes like to 3,000-4,000, right? Until you go fast enough, it goes back to 1 or 2, right? So your engine doesn't work as hard. So it's due to the starting and stopping the whole time that you use more in the city than you use on the highway. So if you're a person that lives in the city and stays in the city, this is probably wrong. The 9 is off. But car manufacturers love to post the average because they're like, hey, if you do a little bit of both, this is what it is. But really, if you stay in the city, you'd be probably using 10.7 most of the time, if not more. Because when they do these tests, they're done in like a closed environment. Like it's all nice. Like they have the little loops and they just drive around it, but they're not like actually driving in the city when they do their tests. And so they post what they have tested in the lab, so to speak, right? So it could be even higher than 10.7. So it's almost 2 liters more per 100 kilometers when you're driving in the city with this particular vehicle. Okay. Now, so the lower is better in this format. But when you're going to the US has something called MPG. It's miles per gallon. Yeah, they do gallons. They don't do liters. A gallon is almost 4 liters, right? So when you go to the States, some of you are going to buy a vehicle from the States, perhaps. If the higher this number is better. We're not going to really deal with MPGs in this course, but I want you to just know, because here the more miles you can drive for every gallon, the better. But here, the fewer liters you use to drive 100 kilometers is better, right? So for us, this is what we're focusing on. Smaller fuel economy is lower cost for you, okay? All right. A fuel economy of 7.4 liters per 100 kilometers literally means, so this is a fuel economy here. It means you use 7.4 liters to travel 100 kilometers. That's exactly what that means. And some of you are like, yeah, I knew that already, but it's just making sure you understand. The fuel economy of your vehicle can vary depending on when you drive. I dislike rush hour with a passion, right? Like I try to avoid it at all costs. If you go off of Sisler, right? Sometimes my wife's like, I need you home like right away because we got to go shopping or whatever. I'm like, nope, I'm waiting until 4:15, 4:30, and then I'm heading out. If I leave right at 3:30, you know how traffic is, right? It's like start, stop, start, stop, start, stop, and then all the construction workers want to merge in, right? So I don't want to go during rush hour. I'm gonna save fuel and frustration and stay in. So when you drive makes a difference. How you drive, if you drive like a jackrabbit, that's a term. Like if there's a stop sign here and there's another stop sign there, some people floor it from this stop sign to the other stop sign, right? Or you have a green light here, there's a red light there, you floor it to get to that red light. Why, right? Just time it, right? If you look 3 traffic lights ahead, it's like it's still red, so I'm just gonna go easy on the throttle and then try to get another green and get a green wave, right? So don't drive like a jackrabbit if you want to save gas. Types of equipment installed. If you have a truck and you have like a very heavy duty bumper installed in the front, those like the nice chrome ones, they're heavy. They're going to actually increase your fuel economy because they're heavy, and the heavier equipment you have, the more you use gas, okay? Conditions of the vehicle's engine, right? If you don't change the oil regularly, if you don't maintain it and do everything that needs to be done, it's going to start using more fuel. That's just a fact, okay? All right, let's keep going. Manufacturers voluntarily place fuel economy labels on new vehicles. The labels will tell you the city and the highway fuel economy of that particular model. The city fuel economy vehicle is different than the highway. So city fuel economy, different than highway fuel economy. Highway, right? Highway is smaller than city. Okay? And then I talk about the US there, but don't worry about that. That's just FYI, your own information if you ever go there. And by the way, there are ways you can improve your fuel economy by just watching your throttle. Also, there are additives you can add to your gas tank every once in a while to clean the cylinders and the pistons and all the components, because there's a carbon buildup, right? Because there's explosions happening all the time, and sometimes there's carbon residue. And if you add that to your tank every once in a while, it costs like $10. Seafoam is a very good brand if you ever want to go with it. I buy one of those every once in a while, and when I gas up, I just add it, add a little can to it, and it will clean your engine as you drive and improve your fuel economy. So things to keep in mind. All right, next page. Let's do some math here. Maybe I will add a note at the top. Fuel economy questions can often be solved using proportions. So proportions, right? You have a fraction here, equal sign, another fraction there. And I'm just doing hashtags to fill in, right? But it's proportion, so you'll cross multiply and divide. Most questions can be solved like this. So just a disclaimer here. Okay, a car is driven 280.2 kilometers and it uses 26.78 liters of gas. Determine the fuel economy of the car. You use the formula, right? Fuel economy is liters distance times 100. That's the formula for it. Make sure you have that on your study sheet. Okay, so if you have a blue study sheet, where's mine? So just giving you, right, there's new, used, finance, lease, and then you should have a fuel economy, right? Fuel economy does not use up a whole lot of room, so try to make it nice and small, right, that it fits. It is also on your yellow formula sheet. So if you don't want to take up space on this, but I always like to have everything in one spot, to be honest. Most of my students, by the time the exam shows up or whatever, they don't even use the yellow anymore. They just use their blue study sheet because they have it filled out. Okay. Okay. So we're going to use this. Liters, they already tell you how many liters you've used. Right? So you put that up there. The distance you drove, 280.2 kilometers, and we multiply that by 100. Let's put fuel economy at the beginning here. Plug in the numbers like that and come up with an answer. And we get 26.78 divided by 280.2. Hit equals, and then multiply by 100. So it's 9.56. 9.56 liters per 100 kilometers. That is the correct way to answer that one. Once you have the fuel economy, you can use that to answer a number of questions which will follow, B and C. So B is asking, how much fuel would you need to drive 1,500 kilometers, right? If this is true, now you can predict things, right? So you start with your fuel economy. So for B, I'm going to start with my fuel economy, but I will write it as a fraction, which it technically is. Okay. I write my fuel economy like this. And on the other side, I will know one of the two. In this case, I know the distance that I'm planning on driving. So because distance is at the bottom here, you simply fill in the 1,500, matching kilometers with kilometers. Make sure your units line up. You can't put the 1,500 in the numerator because you have liters across from it, right? So that's what they're asking for. So put your X in there. And then you cross multiply and divide. So you go cross multiply and divide. And so show me the work. So 1500 times 9.56 divided by 100. 1500 times 9.56. I always like to hit equal there and then divide it by 100. So 143.4 liters. Required. So if you wanted to travel 1500 kilometers, that's how many liters you'll have to use with that particular vehicle. That is assuming that your fuel economy stays the same. Okay, it stays at 9.56 over 100. That is a little bit inaccurate because let's say you travel to British Columbia or Alberta. As soon as you hit the mountains, what do? Your car has to work super hard to get up that hill, and then it relaxes going down. But your fuel economy will probably go up because your engine has to work so hard to get up. Okay, but what do? You just up it a little bit. It's like I calculate 143. Well, I'm probably going to use 160 liters, right? In reality, you'll kind of like estimate a little bit on the conservative side. Okay. C, what distance could you travel with a full tank if it had 70 liters? That's kind of like what car manufacturers will call a range. Like what's the range on a tank? Like how far can you get? Start with your fuel economy again. That's what I said, most questions can be solved using proportional reasoning. Start with that if you have it. And on the other side, right now you know the liters. Liters are on top. So you can calculate the kilometers underneath. And in this case, the 70 is up there, right? So you're going to multiply down and divide going up. So it's 70 times 100 divided by 9.56. And that's 732.22, right? Kilometers on a full tank. So this question kind of went from figure out the fuel economy, and then we use the fuel economy here, and we also use the fuel economy here. Right? The fuel economy is kind of like pivotal to figure out the other questions. Okay. Sometimes the question gives you that right off the bat, then you can skip the step of figuring it out. Just set up your proportion and figure out what do you need, liters or kilometers. Right? Make sense? Yeah. All right. Let's keep going then. So I'm just going to add a few layers to this. Like we're going to calculate how much money you would have to pay if you knew the cost of gas, right? So the odometer, that's basically the little place on the dashboard that tells you how many kilometers you've driven, shows how many kilometers you've traveled. Julia filled her gas tank. And so she fills the gas tank, writes down the kilometers she has at that point, and then when she fills up again, she reads the odometer again, because we want to know the difference, right? Calculate Julia's fuel economy if she filled up 45 liters. So for A, they want the fuel economy, so you have to use the formula for this one. And we're told that it's 45 liters. And watch what I'm going to do here to show what I've done. I'm going to take the final reading in kilometers minus the initial reading because it's liters distance times 100. So the next line is going to read fuel economy is equal to 45 liters, and I will just figure out that difference. And that's 345.8 kilometers. And we're going to multiply that by 100. And that's going to give us our fuel economy. So 45 divided by 345.8, it equals, times it by 100, and it's 13.01. 13.01 liters per 100 kilometers. So when I go hunting with my friend, we split the gas bill. I know that my fuel economy is about 13, let's say in this case. How far did we drive? 200 kilometers, right? So I'll say one way is 2 times 13, right? Because it's 200 kilometers, so that's 26 liters. And then back is another 26, so that's 52 liters, right? I multiplied in my head like how much it is for fuel. I look at the gas price, and then it's like, hey, let's give me, I don't know, give me 30 or 40 bucks or whatever, right? Like you do the math based on this. Or you just use the how many liters you've used on your gas, on your fuel tank, right? Some people just look at that, but that's not as accurate, I would say. Hold on, B. Total cost of fuel is, so calculate, right, the total cost of fuel if it costs $1.209 per liter. So we'll say, in this case, cost will be the 45 liters, multiply it by what it cost per liter, right? Because we were told how many liters we used. She used 45 liters. And that's $54.41. Because she used the 45 liters. So cost is always liters times the dollar amount per liter. That's how you find the cost of fuel. Third example. This one is a little bit more, this isn't as guided as the other ones, but you should be able to do something like this. Toyota Tundra has a fuel economy. I'm going to highlight that because that means I don't have to calculate it. If we made a 375 kilometer trip, calculate total cost of fuel if it is this much per liter. What I'm going to do is I'm going to do step 1, calculate liters used. That's going to be my first step because if I want the cost, I need the liters. So I'm going to say, remember, most questions can be solved with a proportion. This is what you start with. 12.3 liters per 100 kilometers is equal to the amount of liters for 375 kilometers. So you're going to figure out the liters you use there. And so you cross multiply and you divide. So it's 375 times 12.3 divided by 100. 46.13. Let's use it all, right? Sorry, it's 125. 46,125 liters. Step 2, total cost. So the cost here would be 46.125 liters times this, right? Because we just figured out how many liters we used. So we carry that with us. And that is 55.77. That's your final answer, right? Cost of fuel. One more here. Right. So this car here has a fuel economy of 9.1 per 100 kilometers. If you use 32 liters for a recent trip, determine the distance you traveled. I want you to try that right now. See if you can do this. Let's take 2 to 3 minutes and give that a try. Fuel economy is given. I have a pretty good feeling that I'm going to have to start with it. If you use 32 liters, that goes up there. The distance you traveled, which will be in kilometers, right? Cross multiply and divide. 32 times 100 divided by 9.1. That's 351.65 kilometers. Clearly indicate your final answer, folks, okay? On a test or quiz, just say this is the answer, circle it, or write next to it, whatever works best for you. And by the way, I always sometimes I have to go back. It's like, wait a minute, right? Your age, did I know this? You don't add taxes to fuel. The price you see on the pump has a bunch of taxes already on it. Like, you don't know all the little taxes that you pay actually on fuel. So never add taxes to a fuel question, okay? It's always what you see at the pump is already fuel taxes included. So don't add tax. Maybe I will add that. I want it more at the beginning. Maybe here somewhere. Gas prices include taxes, right? I just make that. Gas prices include taxes already, so don't add tax ever when it's fuel economy. Just leave it, right? Somewhere, I don't know, maybe just in your brain, make sure you remember that. Okay, talk about the last thing here on page 42. I just want to talk about operating costs. I just have a few examples just to have, and you should probably have 2 or 3 on your study sheet on operating costs. But here are a bunch that I was thinking of, right? Getting your brakes inspected regularly, change the oil regularly, rotate your tires regularly. What is a tire rotation? Anybody know? Joey? That is balancing the tire. Yeah. Did you know that a tire needs to be balanced? Have you ever seen those little lead clips on the side of the rim? Like, there's a little lead clip on the side. Maybe you've never paid attention, but they actually balance the tire so that when they put it flat, it won't turn. and find its center of gravity. They just center it. So there's a little aluminum clip, or lead, it's lead, clip on the side rim to balance it. But that could be added to this, balance your tires. Tire rotation is this, okay? If your car has 4 tires, let's say your car has a front wheel drive, okay? What's going to happen to those tires is that they're going to wear out sooner than the rear. So what do you want to do? Once a year, mechanics or shops, they will actually do this. They will take the front two, swap them to the back, but also cross them over, okay? Just in case there's uneven wear. If you do this, then you're making sure they're wearing out at the same rate everywhere. Okay, you actually extending the life of your tire. If you leave them as they are, the front ones will need to be replaced a lot sooner than the rear. So that's tire rotation. It doesn't cost much. You can do it even yourself at home if you have a jack, well, or you get someone in the family that knows how to do it, right? Take the tires off and rotate them, okay? Oil filter replacement needs to be done every time you make an oil change, by the way. Coolant flush, the coolant, it needs to be done every 80,000 to 100,000. Your car will have that in the manual, how often that should be done. Wheel alignment, this only needs to be done if you do some work on the front of the car, like suspension, shocks, anything that's done in the front of the car where you steer, you need to align it. Don't just hope for the best. It's laser thin, the margin, it's laser thin. So if your car is even a little bit off alignment, you're going to wear your tires out a lot quicker. Right. Rust proofing. Did you know that there are places you can take your car to rust proof it? They have like thin lines, they call them snakes. So they will like insert it into every panel of your car and spray oil in there. And the reason being is that you don't know this, and I might not even notice that there might be some water buildup in your door at the bottom. It goes inside the window, down the panel, and the water just sits there for years. And that's how rust starts. When you see rust, it's been happening for years already. You're just seeing it now. And so they spray oil in all those cavities. And oil, obviously, right, it repels water. So that is a couple $100. They recommend doing it every year. Even if you do it every 5 years, it will help, right? So look into that if you get a car, if you want it to last longer. Wiper blades, replace them regularly. They wear out a lot quicker than you think because it's just rubber and it's hot, it's cold, they rub against the windshield, they wear out. So every year, every 2 years, if you notice they're not doing the job, replace them. They're not that expensive, 10, 15 bucks for 2 probably, or 20 maybe. Air filter replacement. So your engine has an air filter and it filters the air before it goes into your engine to be burned, right? If that's dirty, your engine cannot draw air and it will actually increase your fuel economy, meaning it will go up, like you use more gas because it can't get enough air. So it's not as efficient. There's something called a cab filter. The newer cars, they have a filter. It's behind the glove box. If you take the glove box completely out, you'll see a filter behind there, and it filters the air coming into the car. So if you want to breathe fresh air, replace that every year or 2. Okay? If you have an air compressor at home, if your parents have one, you can just take it and maybe just clean it. That might also do the trick, and then you don't have to pay for it. Battery replacement, that's just as needed, right? But that's there. And then there's a difference between preventative maintenance and emergency repairs. So you always have to think of changing the oil regularly prevents major breakdowns. Right? Your engine will last longer, it will run smoother, it will just do much better. Rotating tires prevents uneven uneven wear. Rust proofing prevents rust from forming in hard to reach areas. I think I'm gonna do it this fall. Just gonna take both of my cars, make an appointment. It usually gets really busy in the fall. And they also spray the whole undercarriage of your car with oil, which is kind of like, right? But mechanics kind of hate it. Like if you take it to a shop, it's all oily, but it also prevents rust, right? So I'll try it. Okay, worst case scenario, you can pressure wash that off. So that concludes fuel economy and operating costs. What I would like to do at this point is I'm going to